Hello everyone, welcome back to Structure. Now we have to continue to Graitec Advanced Design Basic Level 2, how to model and how to use some function in Graitec. Now let's start. We have to click on the top view and active work plan. The previous tutorial we just complete in the home menu, and now we have continue to other function by using opening, by using convert line, and we will preview another option. Now we have to create one planar element or slab element. I just click double enter, and after that you come to opportunity, you click on opening. You see here you must select contour or close line to create opening. So you can create opening directly. You have to create a line and then you have to convert it to opening. Now I have to draw a line. I can draw in this circle, and I draw in the circle. Okay, and input the circle. Now we input here. Okay, input the radius. The radius is 1 meter, and the number of sides we divide it into 16, and input the. Now we just create a circle. You see here a circle, and after that you can move it into the planar element. Now we have to select on move, or you can copy it. Now just copy, and you can drag to other location. Now just to preview it in wireframe. Yes, you can check and click and copy. Click on the vector. You see here you can change for the snap. You can disable. Okay, now I want to add in this one. Copy another one in this location, and okay, we just delete and create another line. Enter, and after you have to complete line element. This one is a circle and this one is polyline. Now we have to convert it. I just to select on the object, and I hide it. After that you can click on the object and you come back to opportunity and opening. You see here you can convert line to other object, but now we have to start from the opening. Now we finish opening, and we come back to show the planar element. So the opening will be automatically convert based on the line you just create. And this one is a hole. You see here there are 2 holes and 1 polygon hole. By just create from the line element. After you create line element, you can convert it. You cannot create a hole directly without any line convert. Okay, see here it is line and element, and you can delete your line and show a planar element again. And after that you can assign for the support 5500 for backfill soil. Sorry, stiffness. Okay. Now you can view it as solid element. This one for solid element, and you can hide work plan. You can hide elastic spot, and you can show it again. Okay, now you know how to create a hole in a slab or in the planar element. Now we have to create another option. Just create line. You can click on finish, or you can create polyline. Now just take it yes, and click on the line. Come back to eternity and convert line. You have to convert line to planar element, and convert line to the structural element. Do you want to delete the headline? Okay. If you want to delete the headline, this original line will be deleted. If you want to keep it, you have to click on no, and I want to delete it. Yes. As you see here, it converts to structural element. You have to assign it by clicking select and check for the property is the concrete. You can change the concrete strength. You can import the concrete strength. You can import from library. Now I want to import 30 megapascal, and you click on the C. Now come back library 30 and import. Okay. Now come back and select on the 30 megapascal, and you see here, you see for the section, you can change section, change to 20 multiplied with 60 as you want, and okay. You see here the section will be updated automatically, and you can change for other element. 240, click OK, and we have to view again in the top view, and now we have to select, and you can select by the material and the cross section. There are two cross sections for the linear element. See here for the section 20 multiplied with 30 centimeter, there are two, and for the 20 multiplied with 60, there are one element. Click OK, select one element. Now I want to control and pick right mouse, click, and come back, select by criteria. You see here the object is 3, and the object 20 multiplied with 30 is 2. There are 1, 2, and for the 20 multiplied with 60, there are 1, 2, and 3. Okay. You can check in the option, or you can select based on the thickness, the coordinate, and for the type, you can select for the geometry. For the planar element, this tile element is set here, set is only 1. click OK. If you control and press the right click mouse, drop and drag to another location and come back. Check the cell number E2. You see here E2 now. Cancel. Now you have the basic how to model, how to convert line object to whole, and how to convert line object to textural element. This is very important too when you import from the file, when you import from AutoCAD file, and you can model any shape, any type of structure as you want. You see here, this one you can convert from the line element to textural element. Now we have to start for the other type, and we try to convert it to the textural element again. This one is the polyline with the close. Okay, close, no opening, it close each other from the original to the earned coordinate. Now we have to try the object line to the area of textural planar area. Click on it and click on alternative again and convert line to the planar element. You want to delete the headline. If you want to delete this line, will be deleted and convert to other planar element. If you want to keep, you can click on no. Now I want to delete it. Yes, you see here, you create the planar element or slab by using the boundary line. This is very good function when you have special shape or any irregular shape. You can model it in AutoCAD and you can import it as the file into the Graitec design, and you can convert it directly by using the option. It is very good option. You can convert for the beam, you can convert for the column, and you can convert for the slab. Now we have to go to other option, other tool. This is for the mesh. You can preview mesh. You can subdivide as the meshing. Now we have to go to the split load. We can split load, but now you can merge object. The core axis, you see here, this is the core axis. You can try to show the core axis of objective by display, and click for the geometry, modeling, and linear element, and you show the core axis. And for planar also show the core axis. Okay, you see here, this is the core axis or also our element. The red is its axis, and for the this one is green is the y axis, and the upward is z axis. And for the beam element, the along element is x axis, and this one is y axis, and the upward direction is z axis. Now you can change. You can select this object, and after that you come back to eternity and core axis by direction. You can change. No, again core axis. Okay, you can change the core axis and click it. Now the core axis change with the direction of your edge. You can see here. If you want to to make your local RC parallel with the global RC, you can try to change it again and again. Okay, now the set RC is up, is correct, and we have to try now if position is correct with the global RC. In the Go practice, you have to model the global RC are the same with the global RC. It is easy to check, and in case you had in case you forget to check, but you can remember about the global RC and local RC. You always use the same sign convention. Helps you to avoid any error during analysis. When you analyze without any discipline, it is difficult to analyze the example. In this planar element, I draw the local RC in this direction and y-RC in this direction and z in this direction. But for the other flat, you see here the x-RC in this direction and the y-RC in this direction and z-RC in this direction. It is pretty difficult when you analyze the same two model, two elements in the same model, and they are the different sign convention in one model. So you have to make sure every element you use the same sign convention. See here, it is the same. Now I want to make this one the same. You see the subtraction is going down. Now we have to check the option by change. Click again. Now the z-RC is going up. You see here, the going up, and you have to continue. You see each one is okay. You can consider it the same in the same direction. Okay, in the same direction in x and z, local RC x and local RC z, local RC x, local RC z, and local RC y. It is the best practice when you analyze the complete model, or there are two or more elements with the same model. You have to make everything is the same. It is easy to analyze it and to design, and also easy to make a structural report when you output the rebar, the internal force, and for other analysis. It is a very good concept when you apply the concept when you modeling. Okay, you can display it when you assign load, and after assign load you can show the local RC of each element. After that you can take a screenshot to make a report like this one. I call it. Now I have to make it bigger like this one. I show the model and I click delete, and this one I call it rename 3D view. Okay, you see here, you can show and show it for the report. When you generate report, you have to make for the perspective view, for the local RC, for the internal force, for the applied force, for the analysis design, and for the design design. You use the same concept when you want to generate the report. You cannot output a report with the text only. It is very difficult to check. You have to output with the text combined with the visual you by using the picture screenshot in the option, you can make the report with the touch and include with the 3D view and with the analysis result and design result represented as the graphic. Okay, now we have to continue to Opportunity again, and you can check here for the seal view. You can check for the duplicate, match property, opening, convert, split load, merge, plan symmetry, shoot intersection, auto lintel, and this one for renumbering. Now I want to display for the planar element, line element, and I want to display about the ID. Okay, we have to show about the ID planar element. We have also show for the ID. Okay, you see here this 1 2 3, and for the linear element, for the beam element 1 2 3 4 5, and for the planar element 1 2 3, and you can renumbering all object by using a tool renumbering. You can select the orientation, reset, and renumbering start from the 1. Okay. So is this one is I want to change it to 100, and this one I want to change it to 300, and after that you can renumbering that number by clicking this again. Okay, you see here the number will be changed automatically. 1 2 3. Is here another good application when you want to renumbering your structural element. This one is for the linear and for the planar, and this one for the support, and this one for the load. Now we have to go to analysis. Here you can do not analyze it without making the surveys. At least you have create a survey for the structural element, so you can create analysis. Now in the case if I don't want to create a survey, we had to try to run. Now click on all object, and you assign for the support again. Okay, now we have to assign for the support for the beam element. You have to enable it again. You click on the analysis, and you can only analysis for the SE calculation, or you can click on the OC calculation E for the reinforced concrete calculation. Okay, now let's start from here. You can check about the code material is 25, this one 25, this one 25, and you can control click on the 3 and you can change the material as you want. And you see here the thickness, you can change the thickness to other thickness. Okay, and the size, this one is the size you have to switch. And this one for the cover, concrete cover. Now I want to take concrete cover to 4. Okay, everything now complete. Okay, complete. And we had to check for the linear element. This one we want to create an analysis for the beam. We call it beam element, not a column element. And after that you can create you can check for the cover. Now concrete cover, I want to use 3 centimeter. And the design we enable to calculate. If you don't want to calculate object, you can untick the option, so the object is not for design. You can analyze it only without any design. Okay, now we have to start. To start to analyze it, click on the icon, click on OC design. Okay, you see here the program has detected a certain number of warnings that can be viewed on the command line. Do you want to continue to analyzing model creation? Now I want to check. The warning is no service are generated, so you have to create load case. Come back to model, home, and click on new. At least one load case must be created. Did load. Okay, click on the load. If you have another load, you can create. Now for the line load, and select and control right click, load, select. We apply the 2 kilonewton per square meter for the planar element, and click on auto scale. You see here, now you have to check the directional load -2. Okay, you can display for the load, check for the loading and point planar element, check for the intensity and unit. Okay, you see here the intensity is 2 kilonewton and the unit is the intensity is -2 and the unit is kilonewton per square meter. Now you can create analysis, but you have to create load combination. It is very important to create load combination. By create simplify combo, you can create simplify combo, generate. You see here, this is for the American code. Click OK, and come back to analysis. Click on analysis model and click on OC calculation. Or another way, you can click to analysis tab directly and click on the OC calculation. Click on OK. Now you see here the warning appear. Error linear element 1, element 01, invalid concrete cover. You can change concrete cover, and for the linear element 2, 3, 4, 5, you can change for the concrete cover. Now don't want to focus about this. If you come back to analysis and you click on the open the current analysis, so we will be look into the previous analysis model without any rerun it. Okay, click on OK. You come back to analysis result. If you come back to model and you go to analysis setting and you create new, this model will be calculate new analysis based on your requirement. Okay, if you want to click on still, the option we create a new analysis, but because we just create the previous analysis, so we had to look in the previous result. Click on OK, and you can check for the deflection. Okay, for the deflection, and you can do animation. Or you can check for the force. You see for the ultimate load, or you can check for the internal force. And for the planar element, you can check the moment. This moment is according with the local axis, not global axis. But you have to orientate the local axis with the same direction on global axis to prevent any error before you analyze the design. As I mentioned you in the beginning, you can check. Now click on the EH. Okay, EH, and for the linear element, for the beam element is by y. Okay, you can change for the by y. Okay, by y. Now in the option you can check for the reinforcement. You can check for the AY reinforcement. You can check for the AZ reinforcement, longitudinal reinforcement. You see here for the longitudinal reinforcement. Now I want to view it in the top view. And come back to result, and you want to show for the planar element. It is the it be for the bottom in each direction. The rebar in the bottom layer in each direction. It is for the local axis. You see here. And you can check on the result setting. And for the concrete, the rebar linear element, you can click on the map view on the center, view on the grid, view on the average. You can click on the isolate line. Okay, ISO region. Click on OK. Or you can show the result directly at the value. You can click for the value. Okay, now you see here the T for the value or the rebar in the bottom along the edge direction, along the local edge direction, local LCH. You see here for the planar element. And this one for the longitudinal reinforcement. You can check for the top and for the bottom. For the top, for the bottom, and for the bottom and for the top. A B Z for the bottom, A H for the top. This one A H for the top, A B for the bottom. And you can also create the report, but I don't want to focus about how to generate the report. We just focus about how to delete, how to draw, how to know about some function in some object, some command in Graitec. After we complete the basic level, we will start to design and generate the complete design report using Graitec. See here, this one for the beam, and for the manage you can click on application. You can check for other option. You can change the project name. Okay, you can change this thing here. This is T. You can change configuration, but you can change it in this degree. You have to visit and change. This is the same. Mesh, you can correct the mesh size. You can change it to 0.5 or 0.1 as you want. Now I just want to keep it 1 meter to make my PC run it faster. And you can check for the count. You see here the linear element, the total is 5, 1 2 3 4 5, and the planar element is 3 1 2 3. Rigid point support is 9, elastic support is 3 1 2 3, and node, the total node is 895, and the total load is 3. Total planar load 1 2 3, and the total is 918. Available memory, the maximum available memory for my computer is 16 gigabyte. Click on OK. And for the design material, this one available for the integrated with the OMD. You can do this type directly in Graitec design, advanced design without integrated with Graitec OMD. So in this one, I just to make it simple by clicking this boundary of the slab, and you have to right click and open design with design module. After you export it to the design module, the option will be activated. The option of design module will be activated. Now waiting the software to integrate it to the design module. Okay, now you see here, home, tab, authority, and let's see, will be deactivated, but the only one tab can be used is the design module. You can design it by define grid or define geometry. See here, this is for the opening. We do not have beam and column or wall. And design setting, you can check for the design setting for the ACI code. Slab reinforced concrete, this is the default we select in the beginner is 30 megapascal and concrete cover is 4 centimeter. Close. And for the rebar assumption, we use based on the film base, we not use for the strip base. Strip base is a traditional method. Film base is for the finite element methods. You see here the maximum hook is 5 times all the diameter of rebar. You can change. Solution top, bottom, you can change. And after that you can check for the load combination. Here dead load and light load and combination, or also complete combination design. This for the AISC and ACI code. Click on cancel and you can run calculation. You see here the warning is the necessary and correct length. This is for the incorrect. You can check for the iterative drawing. Now drawing is around 82, 83 to 47% Graitec, almost complete. You see here the rebar, reinforcement bottom scale. Use the film base, not use based on the strip base. This one the information about the material used, and also calculate the total weight and the formwork. And this one for the ballast. You can check for the ballast.